Hi everyone, good morning, good afternoon, or good night. My name is Eduardo Camargo, and today we're going to talk about Metaverse. This next session will walk us through mixing Metaverse and blockchain concepts in a proof of concept. Our speaker for the day, João Caleffi, one of our innovation leaders, will explore concepts and technologies for both areas. I can't wait to see it. But before we jump into the session, a quick reminder. Follow us on social media and check out sessions of our Global Devweek. Use the chat to leave your comments and questions. And without further ado, take it away, Caleffi.
All right, thank you, Eduardo. Let's get started. So, why we did the POCs around metaverse and blockchain? First, metaverse is a technology that's been around for the past years, and it's receiving a lot of investments from very large companies such as Meta and Microsoft, and even Facebook renamed itself to Meta to give more attention to this topic. Blockchain as well have received a lot of it's been in the spot for quite some time due to cryptocurrencies and NFTs, and it's also aside from that is also uh, thought about this from some experts as being a foundational element of the metaverse. So for this, Encora invested in some proof of concepts to mix both technologies together in some POCs around a gym, virtual 3D environment for doing exercise with trainers and participants. And also we integrated that with an outfit marketplace based on Ethereum. So the agenda will cover metaverse and blockchain overview, just so you get more into the concepts required for understanding the POCs. Then we'll dive into the gym and the marketplace exercise we did. By the end, we will wrap up, providing some takeaways about what we could understand from what have exercised in these POCs. So let's jump into the metaverse overview first. Metaverse is a definition that several people will bring you different definitions. So we like to use the one from Gartner, where the metaverse is a collective virtual open space created by the convergence of virtually enhanced physical and digital reality. It's physically persistent and provides enhanced immersive experiences. And to deliver those, some companies have already built their own solutions to create such immersive experience, trying to converge physical and digital reality. So we have Horizon Worlds, Microsoft Mesh, Decentraland, and Fortnite, even in this case, where Ariana Grande played a concert within the game. But to support the metaverse, some key concepts are very important to understand. So the need for interoperability, the need for decentralization, and the need to address equity and accessibility requirements. So going through each one, so for interoperability, the idea is that there will be only one metaverse, not many. The way as we do, we look at the internet today. So we move around between pages by using web links, but still it's a one big network where we can switch between contexts, different immersive experience in two dimensionals, but the metaverse should follow the same principle. So to get to that, there's a very strong need for standardization. There's an organization that's already doing that. So the Metaverse Standards Forum is working on providing such standards together with the companies working technologies around this topic to make standards available so you can have more of this interoperability in place. The other aspect is equity and accessibility. Is touch the point that there should be no restriction of gadgets or hardware necessary for people to join the metaverse. Virtual reality headsets should be something that will enhance the experience, but not to be a mandatory. So for time being, using smartphone and computer screens, computer cameras should be enough for allowing people to get at least much of this experience through the current hardware mostly used by everyone. And the third aspect is decentralization. So the idea of, as explained before, the internet, no one should own the metaverse. So nobody company should be the only one hosting the metaverse itself. As the internet, we have different web page, web servers, different companies serving subsets of the internet, and it always works in a kind of a one big mesh of information, right? So the same decentralization should happen to the metaverse. Another concept here is that everyone should be able to own things in the metaverse, and this would allow us to pick anything that we have from one place in the metaverse, take it to the other place in the metaverse, and still be ours. So the decentralization of this, of ownership of stuff, of things, should be relevant as well for the metaverse. But so, for instance, example here, you could buy a skin for playing CS:GO, and you will be able to take it to Fortnite and use it in there as well. But what we have today is a very proprietary siloed environment. So although I explained Horizon, these examples, Horizon Worlds, Microsoft Mesh, Decentraland, and Fortnite, these are all siloed environments. They address their own requirements on what metaverse is in their perspective of using more storage, virtualization, or more digitalization of the environment, and they are owned by proprietary companies. So they're very sealed in their lack of interoperability between them. So this is not a real metaverse. So we are waiting for the real metaverse to happen, and we will keep following up to the next steps that community is taking. For addressing the blockchain, a quick intro about it. So blockchain is basically a decentralized database of transactions that's shared across all the networks that participate in the blockchain. The key characteristic of the blockchain is that the database and the data is immutable. So you are not able to change things that are committed right in the past. So you can only add new transactions to the end, and you do it by building blocks of transactions, which will be attached to the end of the blockchain. So that's why the name comes from these linked blocks to form a chain. And the link between these blocks is achieved by having cryptographic hashes in place. So this is another way to guarantee the network is hard to be tampered. So even if the blocks is changed, the computational effort to guarantee that everything is in sync is too high, and this yes, to a practical level to happen. So the established networks such as Bitcoin and Ethereum would be hardly be tampered by anyone. Another concept that's important when deciding how to design your blockchain solution is to decide what the types of blockchain you need to use. And there are two main categories for that. So the public or permissionless blockchain technologies and the permissioned one. For the public ones, the idea is the blockchain will be openly available for everyone to participate. So everyone can create a node and participate in that network. All the information registered in the ledger, in the public ledger, will be available to anyone to access it. There's tools for searching data in the blockchains, these kind of blockchains, and participants are usually anonymous. They have an ID where that will be used for signing transactions, referring to what is yours in the blockchain, but mainly anonymous. The most known technology for this are Ethereum and Bitcoin. For the permission type of blockchains, the intention is to have a more granular control of who can access, and the participants are identified, so the information is controlled. These key use cases are usually for you have a set of companies trying to create a marketplace or exchange information in a decentralized way. And for this case, they, for instance, can use the Hyperledger Fabric technology. Another key concept of blockchain are smart contracts. Smart contracts are basically programming codes, functions, or methods that you store in the blockchain itself, They're called externally, and they can change data, for instance, to change ownership from assets like NFTs, or they can be used as a building blocks of a decentralized apps. So applications that are developed by using smart contracts as the foundational element. For our talk here, what's really important and what we have used in the POCs is the token standards. When you're developing a smart contract for having your token available to be exchanged by others, you have to follow some standards, or it's the best practice to follow some standards set by the community. So your token is usable from many tools, not for one specific tool. So there are three main token standards that we have followed. So ERC20 focused on fungible token standards. Fungible tokens are the tokens where you have one type of token that has same value and it repeats in certain amount. So you will think about a Bitcoin here. One Bitcoin will always be one Bitcoin, right? And then you have the ERC 721, which focus on non-fungible tokens. So the NFTs. In these, you have a uniqueness of the asset you are trying to manage there. So it's really used for digital art. So a person wants to own an image, and you'll be the only person owning that image, and that image is unique. Then use the NFT. And there's the third token standard that's focused on more. It's more broad than the first two, but it englobes. But the first two, it focuses on semi-fungible tokens, where you can have a combination of both. So you can have a certain amount of a certain token that you have certain ownership associated to those as well. So this last one is the one that we have used here in the POC. Another important topic here is that every operation that we have to store and register data in the blockchain will demand certain cost, right? In terminology of Ethereum, this is called gas fee. So when somebody is doing a transaction or exchanging something with another person, a gas fee will be required. And the gas fee will be going into for two purposes. So the first one, to provide a miner, the person who's trying to add the transactions to the blockchain, he gets a miner tip, and the rest is burned as a base fee. So these are kind of controls the Ethereum network has in place from the last 2 years to guarantee there's the amount of transaction that's happening in the network is aligned with the amount of effort everyone is spending to make it happen. So let's go dive into our first POC. So a gym in the metaverse. This is a proof of concept we did to create a virtual gym application using metaverse-related technologies. The idea here was to put the trainees and participants in a 3D environment and make it use of movement tracking, 3D scene, spatial audio, voice chat, and also in a client server setup. So we have used several technologies. We'll get to the architecture design later. But we have here achieved a cross-platform application, the 3D environment with personalized avatars, movement tracking, spatial audio, and voice chat. So this is our scene. So what we have inserted into the scene. So it's a multiplayer session. We can allow being a client server architecture. We have the trainer as the holder of this main session, and all the other participants can join and participate on the scene. We have the movement tracking and rendering that happens live when you have your camera enabled. So in the setup, we have the camera appearing on top left, and you can see that the pose the person is doing will be reflected in the avatar. The third thing here to note is spatial audio and voice chat. We have here a TV set, for instance, that when you walk towards it or far from it, you can hear different volumes on the sound. You talk to other characters in the scene, you see that direction is important and relevant for what you hear. And the 3D environment where you have placed the avatars and all the other stuff for the gym. So this is a basic architecture we have built for the POC. So we have a client server scenario where you have in the left the trainer that will be serving as the host of the solution. It get all the application was developed using Unity, and a lot of plugins were used as well to make all the features happen. So for the movement track, we used MediaPipe machine learning library attached with a plugin to Unity. So it captures the movements and translates it to the avatar. Of course, some challenge over there for trying to make the movement more satisfactory, but it's really good for using for that purpose. Then for network management, we use the Mirror plugin, and for the voice chat, we use an external service, the Agora voice chat session, so we could have this exchange of a voice in the scene. Other tools we have used as well that supported this was the Ready Player Me for generating the avatars based on pictures. We have uploaded Scratchfab to provide the 3D model for the gym environment, and many other things that we try to evaluate to see if there was a fit for the use case we were dealing. So just an example here about how the video capture happens in real time. So we have played videos like this, and then we can see the avatars moving accordingly. Of course, this also works with the cameras, and you see that there's some nice work the team did for capturing these movements. So that's for the gym itself. You feel free to reach out to our website and check the articles we have written about it. There's a lot of demo scenarios there and recordings to get more in depth of how the gym is working out. So going to the next POC we did was to attach an outfit marketplace based on the Ethereum to the solution. So the idea was to have to build this marketplace so people could buy and sell outfits and use it in the virtual gym. So we used the Ethereum blockchain network as a basis, and use it also its NFT token standards. With that, we have used additional technologies to support that the POC. So Unity was the basis for integrating with the gym, Ethereum as the blockchain network, MetaMask to enable the web application to interact with the network, IPFS for holding the metadata, in AWS for authentication. But when we started to understand what we needed to do to create this blockchain solution, the first question was, what should we store in the blockchain? And it was clear that some key points they have to observe before designing a blockchain solution. The first one is that the cost. Every transaction that updates and store information will require some gas. And this can be restrictive because of the amount of gas you have, right? Every operation will get expensive. And the other one is speed. You have too much information to be stored. Probably you have to compete with others in the network. They want to set their transactions in the next block. So that's a very important thing. You can get a long time until your request is completed. And privacy. So guaranteeing if you want to use a public or a private blockchain is very important for this as well. So in case, especially because of points 1 and 2, in considering cost specifically, most of the implementations of tokens don't use the blockchain, for instance, Ethereum, to store all the data required or related to a token. So the thing here, or the best approach here, is to store the minimum information that would be the token identification itself, the ownership information, and a pointer to where the rest of the information is. So this is where I in here. So so the strategies for storing elsewhere outside of the blockchain, you have some options, right? So you can store in services more commonly like Amazon S3, that will provide low latency, great availability, but that does not guarantee that the content won't be changed, right? If you place an image in an S3 bucket, you can go and change it, the content of it, but the pointer will still point to the same image, right? But in case for a blockchain solution, the most appropriate solution is to have something that is immutable. And for that, we have used the interplanetary file system, IPFS, that will kind of generate a hash from everything you upload over there, and that won't change over time. So every time you upload the new data will get a new identification. So that's important. That keeps the immutability property that we wanted from a blockchain solution. So what we have here is the architecture we have used. For instance, the web application, we did a localhost. We used the Next.js, Axos, and Tailwind for building it. The application was pointing towards the IPFS network using a local node that you have created. So for fetching the data and the metadata from each outfit, and we were using MetaMask as a jump for getting for managing the accounts and getting to Ethereum. So the app application would show what has to be, what the user has, what he wants to sell, and outfits from others, so we could buy it as well. At the right, we have the unit client host application that we adapted using Ethereum as a C# library for interacting with the Ethereum network. Here we use it in Fruta as a node service provider, so we didn't want to create our own host, our own Ethereum node for connecting to the network. So this is the look and feel about our marketplace. So you can buy, create new, and check your outfits, and also see the outfits as you listed for sale. And all the properties, all the images are stored in the IPFS, and only the identification itself and the pointers are stored in blockchain. Here's how it got integrated with our PoC of the gym. So we had to create a new screen for entering the Ethereum account and also changing the outfit selection, so the person could join the session with its own outfit. And so this is an example of how it worked. And the last topic I want to bring here and discuss with you guys is that the decentralization aspect that Ethereum and blockchain as a whole brings to us. So we have created the Encora marketplace, and it's using storing and interacting with Ethereum network for creating, changing, making transactions to change owners, etc. And we create the Unity application to make use of that. So fetch what certain participant outfit participant wants to use from Ethereum, right? But although we have created that, we have followed the specific standards from the Ethereum community, and also standards that are common to use when creating these kinds of tokens. So there are other tools that can be used in this aspect of decentralization that make it available not just for our own applications, but for everyone else. So Etherscan and OpenSea are example of other tools that can be used to check what we have put in Ethereum, but any other distributed application could do the same. So exploring a bit of what Etherscan is. Etherscan is a block explorer. So as we mentioned, blockchain is a public ledger. So there's a set of blocks aligned for since the creation of Ethereum, and the Etherscan tool is something you can use to navigate in each block, inspect each transaction, understand if contracts are in place as well. So it's a great tool for checking out how your setup was made and investigate how each block was built by others. And if you have, for instance, contracts that are following the standards, and you have contracts that are openly available, you can even inspect the code of the contract with this tool, right? But it's not changing anything. It's just exploring what blockchain, the Ethereum blockchain has to offer. And the other tool is OpenSea, which is a marketplace, an open marketplace for NFT. It's integrated to Ethereum. So if you follow the standards for the tokens and also some standards of basic contracts they have as example, your everything that you stored in Ethereum will be readily available on this marketplace as well. So here the image is bringing an example of the same thing we created in our own application, but navigating through OpenSea, you are also able to navigate into the same things, right? So this is great proof that decentralization really happens with blockchain. So to wrap up, there are some takeaways I would like to share with you. So as discussed, basic factors that are the foundation of the metaverse. So interoperability, decentralization, and equity and accessibility. These are key factors for that. There are a lot of available technology that can already be used and has the capacity to deliver immersive experience. You have proof with our PoCs that we can build some of those, although as I have exemplified, Meta, Microsoft have their own solutions. We create a gym that's only ours as well. So it's still a very siloed approach. Motion tracking via camera or webcam is possible. It's an interesting alternative for not having the requirement for using VR equipment. Blockchain decentralization characteristic can be a key point to allow the sense of ownership and interoperability aimed by the metaverse. And we explained here by using tools externally to what we did. So OpenSea and Etherscan. And a very important part when designing the blockchain solutions that you need to be aware of what you actually want to store in the blockchain, because there's cost involved, speed involved, and privacy involved as well. So that's it I wanted to share.
Sorry, I was muted. So thank you, Caleffi. This was a great presentation. There's so much complexity around metaverse, around blockchain. They're not easy topics at all, right? But I think you managed with this proof of concept to bring out in a very easy to understand way for all of us, for the audience. So thank you again for that. And I hope you all enjoyed this presentation as much as I did. Be sure to leave your comments and questions for Caleffi on the chat. Thank you all once again for this great session. Be sure to check out our Devweek agenda on our official website, and see you on the next one.